Hi everyone. Today in this video, I'm going to give my May SAT predictions and see what you should know, I believe, going into the exam. So first things first, make sure you have a good grasp on advanced geometry concepts. They've been coming up on the past digital SAT exams, but let's just take a look at some questions that I believe could be on the exam. Okay, so this one here. It seems easy at first read, but it actually becomes a bit more complicated. And if you want to solve this on your own, pause the video and then you can watch for the appropriate revision. Okay, so this one says the perimeter of an isosceles right triangle is 26 plus 26 root 2 inches. What is the length in inches of the hypotenuse of this triangle? Okay, so first things first, we need to know the 45, 45, 90 triangle. This is given to you on the reference sheet of the exam, but you should know it anyway. So it's x, x, x root 2. Okay, I'm told the perimeter, so I can sum these side proportions and get 2x plus x root 2 is equal to 26 plus 26 root 2. Okay, so from here though, I can't set like 2x is equal to 26 because that would give me x is 13, which we can see isn't possible because this has to be 26, 26. Okay, so then the key actually here is to factor. So what I can factor out is actually the x root 2, and then this would be the same as root 2 plus 1, right? So I can see if I did multiply this gives me 2x, and multiply this gives me x root 2. Okay, so then going to the other side, I want to have the same factorization happen. So from here, I could say that this would be the same as if I factor out the 26, so 26 root 2 plus 1. And you can see here it gives me the 26 root 2, and here would give me the 26. So then I can divide each side by root 2 plus 1. They nicely cancel, and I'm left with that x root 2 is actually equal to 26. And then I want to go ahead and rationalize out the square root. So I'm going to get 26 root 2 times root 2 root 2, which will root 2, which will simplify to, well, I'll show all the steps. 26 root 2 over 2, which is 13 root 2. And this is what x is equal to. Okay, so, and that seems to make sense because then this would be 13 root 2, this would be 13 root 2, and this would be 13 root 2 times root 2, or 13 times 2, which gives me, just to show all the steps, 26. And I'm asked for what the hypotenuse of the triangle is. Well, it is 26. Okay, and that also makes sense because if I go here and do 26, or sum these together, 13 root 2 plus 13 root 2 plus 26, that gives me exactly what I have above. Isn't it amazing? Okay, so no, this concept could be useful and helpful in solving. Continuing our advanced geometry journey. Okay, so let's look at this question. So here, we're given a triangle, and it says in the figure above, triangle ABC and BCD are right triangles. AD equals 8, BD equals 6. What is the length of DC? Okay, so here, if I wanted to solve this, my first thing that I recognize, this is a Pythagorean triplet. It's a 6, 8, 10. And I need to get the length of DC. Okay, so I'm gonna just label this A and this B, just to show. So if I were to, so for these problems, you want to think about flipping the triangle. Let's see what happens if I invert triangle ABC. So in this case, the B is here, C is here, A is here, and the BD, it's here. Okay, so then I have the hypotenuse here, which is 8 plus A, and then I have the AB value. AB is 10, oops, 10, and our CB value is B. So just to show what that looks like, and then I can use Pythagorean theorem. So B squared plus 10 squared is equal to 8 plus 8 squared. And also we can look here that from this triangle, I can create another Pythagorean theorem so that I have two equations. So this would be like A squared plus 6 squared, oops, A squared plus 6 squared is equal to B squared. Okay, and so let's go ahead and expand the brackets here. So this is 100, and this would be A plus A. Remember to expand the brackets. So this becomes B squared plus 100 is equal to 64 plus 16A plus A squared. And then, let me just make that a little bit nicer. Okay, A squared. And then I have a system of equations, so I can do substitution. I know from here that my B squared is equal to A squared plus 6 squared. So I can also go ahead and substitute that in here. And then that would give me A squared plus 36 plus 100 equals 64 plus 16A plus A squared. So subtract the A squareds from each side, they cancel. Subtract the integers, so it'd be like 136 minus 64, 72 equals 16A, and then divide by 16, and I get that 4.5 is equal to A. And the A value was what I labeled DC, so that would be the answer to type in here. Okay, so if you get a triangle here on the exam, it seems really complicated, always consider flipping it because perhaps that is the trick to solving the answer. Okay, so another concept that could come up and would be good to know are polygons. So here we have the problem, a polygon has 95 sides. If each interior angle is given by 180 p degrees, what will be the value of p? Okay, so first, if I want to find the actual amount of degrees that a 95-sided polygon has, I can use this amazing formula, which is n minus 2 times 180. This will tell me like the sum of interior angles of any n-sided polygon. So let's do that. So this would just be 95 minus 2 times 180, which is 93 times 180. And that gives me 6,740 degrees, which makes sense. It has 95 sides, so it makes sense that there would be a large amount of degrees for the interior angle measurement. Okay, so I know the actual amount of degrees that this has, and it also important, it does say that each interior angle is given by 180p degrees. So expressing that algebraically, I would know that each of these angles, so 180p times all 95 sides, let's see what that equals, is equal to 17,100p. Okay, so what this is telling me is that each interior angle, it has 180p degrees, and that means that each angle, each of those 95 angles, has exactly 180p degrees. So that's why, you know, since there are 95 angles and each angle is the same, that's why I'm multiplying them together. And then now I have two expressions that I know are equal to each other. They're both the sum of the interior angles of the polygon, and I can set these equal to each other. So let's do that. and then divide each side by 16,740 divided by 17,100. And that gives me like approximately 0.9795. And looking at the answer choices, the fraction that gives me that exact value, it is 93.95. And that would be the answer. Okay, but so main takeaways for this problem, make sure that you know this formula could be helpful. And look for language to help you, in this case, like each interior angle, because that could be the key, to solving this problem. Okay, amazing. Okay, so now next concept this concept is at every single exam, functions. I think you'll definitely see some function questions. Make sure you have them mastered. I'm going to go over the things you should know. Okay, so first, this one. This would be, we could consider an exponential function. So here it says f of x is equal to 9 times 4 raised to the x power. And I'm asked which of the following equations represents the function g. Okay, so if g of x is equal to this, all I have to do is substitute this into the original function. So that would just be 9 times 4 raised to the x plus 2. Okay, so from here, always when you have exponents involved in the problems, you want to reverse engineer them. So looking at this, I can reverse engineer it because whenever I have addition with exponents, that means that I would have multiplied previously to have solved the problem. So this would be the same to say 4 to the x and 4 squared. Right, this is the same, bases are the same, it looks like this. It's another way to express that expression. So then I can just multiply 9 times 4 squared, multiply with 4x, and 9 times 16, that's 144. And then you can see I get the actual function, and I get it pretty quickly as well. Okay, but just remember, if you do have an exponent or exponential function, always consider reverse engineering because that could be the key to solving it. Okay, so let's also look at another one. Oh, very similar, but slightly different. So this one, I have 1.84. If you can't see it, this is an x. It's x divided by 4. It says it's divided by the given equation, and it can be rewritten as this, where p is a constant. Which of the following is the closest value to p? Okay, so I have my f of x is equal to 1.84 raised to the x over 4. Another way to express that would be f of x is equal to 1.2 the 1/4 times x, right? Because this would be the same expression. And then I can just now distribute that nicely. So this would be the same as 1.84, like raised to the 1/4, and then I can have x on the outside. So now I just need to see what that's equal to, 1.84 raised to the 4th power. Let's see. It's 1.16467 and going onward. So that's raised to the x power. And then remember, it says that this can be rewritten as, oh my goodness, it looks exactly like I'm trying to make it. So this would be 1 plus p over 100 x. And just to see the equivalences, right? Like this must be like 1 plus 16 over 100 raised to the x. So therefore, the answer must be 16. But you see how once again in this problem or this function problem, I took the exponent a step back to see what it could look like to make it mirror more the function rewritten in the problem. So always consider to reverse engineer exponents for function SAT success. Okay, so continuing our journey. Another function that I think could definitely appear are the functions that deal with quadratics. So there are multiple forms you need to be aware of with quadratics. One which would be ax squared plus bx plus c, standard form. You should also be comfortable and familiar with vertex form, x minus h squared. And also you should be comfortable with roots form. Okay, so let's take a look at this question. It says the function f is defined by ax squared plus bx plus c, where a, b, and c are constants. The graph y equals f of x, and the xy passes through points 7, 0, and negative 3, 0. If a is an integer greater than 1, which of the following could be the value of a plus b? Okay, so first of all, I'm given the x-intercepts here of the equation. So if I'm given the x-intercepts, I can use them to create a quadratic equation. So I'll definitely be using roots form, so these are the two other ones, but roots form, it's y equals a, like x minus root 1, we'll say, and x minus root 2. Okay, so since here it passes through the points positive 7, that means that it would be plus 7 inside. Sorry, negative 7 inside. And here it would be plus 3. Why is that? Because x plus 3 equals 0. So that gives me one of the x-intercepts, which we see here. And likewise, x minus 7 equals 0. That will give me x equals 7. So looks just like that. Next step, expand the bracket. So let's expand. This would give me x squared. I'll just show the steps. Plus 3x minus 7x, and then minus 21. Simplify further. So I have x squared minus 4x minus 21. And then I can distribute the a everywhere. So I have ax squared minus 4ax minus 21a. Okay, and remember this is defined by this equation. So just to show, ax squared plus bx plus c. So from here, I for sure know that negative 4a is equal to b. And I can also see that negative 21a would be equal to the c value. And also with that too, I can see a is simply equal to a. Okay, so then asking for the value of a plus b, well, let's substitute the values in. So I have a plus b. I'll put my a value here. I'll put negative 4 value in for b, so that would give me a minus 4a, and that's equal to negative 3a, right? So I can say the value of a plus b is equal to negative 3a. So first of all, I have negative 3 in front, which indicates that this must be a multiple of 3. So the only multiples of 3 are a and b, so I can completely discard c and d, have a 50-50 chance of getting this one right. And then from here, go back to the problem. It does highlight, it says a is an integer greater than 1. So that basically means like a, remember it's an integer. So if it's the first integer that's greater than or equal to 1, it's 2. So I know a is going to be greater than or equal to 2. And from here then, like a possible value could be negative 3 times 2, because that would be -6. It can't be this one, because that would be -3 times 1, and it says a is greater than 1. So therefore, it must be -6. Okay, but you see how I'm able to derive the quadratic equation by my knowledge of Root's form. And be familiar with the other forms that I posted above, which are just standard form. Sure, you're all familiar with that, but also vertex form, super important. We'll see vertex form soon in a couple more problems. Okay, so another thing I believe you should be super confident with for May SAT, also any SAT, is translations. So be super familiar that if you're shifting up, I would be adding 4 to the function. If I'm shifting down, it's -4. Note that if the equation or the function is shifting left, I add 4 to the x value, and if it shifts right, I subtract 4 to the x value. Okay, so here's just like a little visual. Imagine f of x is x squared. Looks like this originally. You see if it is shifting to the left, it's +1 on the x coordinate, like you see here. Shifting to the right, -1, shifting up, +1 on the function, and shifting down, -1. Super important to know this, have a good grasp. But let's see how that could look. Okay, so here it says in the given function, f a is a constant, the graph of function f in the xy plane, where y equals f of x is translated down, or 3 units down. Okay, so remember, if it translates down, that means that this will be effective. It'll be -3. So just to show, this will be a minus 19 over x plus 5. I know for sure this is being -3 down. Okay, so that's definitely going to be +2. So for sure I can eliminate C and D. I have a 50-50 chance. And then here it says it shifts 4 units to the right to produce this new graph. So remember, if it's shifting 4 units to the right, that actually means that I am subtracting from the x coordinate. So, well, just to make this a little bit better. So this would become x shifting to the right. It will be -4. Okay, so I remember shifting to the right, so it's moving that way. Okay, so that looks and matches exactly like choice B. And you see, like, that's solely me having a really good grasp on what translations do to graphs. So make sure you know this. Could be useful, right? Shifting to the right, subtracting. Okay, let's see another one. This is a classic. So here it's told me the function g is defined by g of x equals f of x plus 5, for which value of x does g of x reach its minimum. So first, it is a quadratic. Remember, if it hits minimum or maximum, it's basically telling me the vertex of the parabola. And in order for me to get the x value of the vertex, which usually we define the vertex as hk, I can always find that by doing x, the x coordinate vertex, or h, is equal to -b divided by 2a. So first, I can just take the, look for the x coordinate of the vertex of the original function, which would be -64 over 2 times 4. And that would be 64 divided by 8. That gives me -8. Okay, so that would be a trap because this is the function here, but I'm asked for g of x reaching its minimum. So I know this is +5. Remember what +5 looks on the actual parabola plane or coordinate plane? So imagine original function here. We'll say it's 1, 2, 3, 4, 5, 6, 7, 8. Let's just say it's somewhere around here. Okay. So if it were -8 to shift, this is telling me that the graph is shifting to the left. So it's actually going to be -5 from here, which gives me -13. So even though it's positive here, and that's kind of can be confusing because definitely the trap could also be just adding 5 to this as well. But I know the +5 on the x-coordinate means that it's actually shifting to the left. 1, 2, 3, 4, 5, like 5 coordinates, everything stays the same. So looks like a parabola, but like this. So shifts to the left. And the one that gives me that, it's -13. That's just another example of how translations could potentially appear on the exam. Okay, amazing. Graph amplification rules. Okay, so remember the final 3 questions of the exam, they're usually pretty tough and difficult. Graph amplification can appear, it's on every SAT exam, but I heard it was on a recent SAT exam and could be on this one. Okay, so you should know the rules. Remember x-intercepts, they always remain the same. And if it's multiplied, so the function's multiplied, for example, if it's multiplied by 2, it'll move farther from the x-axis. If it's multiplied by a fraction, it moves closer to the x-axis. So just to give a little visual what that looks like. If it's multiplied, for example, by 2 of f of x, we can see here it would look like this, and then if it's multiplied by 3, it's actually getting closer together, but it's moving farther from the x-axis. And same here, they appear like this would be 1f, and if I multiply 1/3, it gets even bigger because it's getting closer, like you see, closer to the x-axis. Okay, so let's just see a problem in action. Okay, so it says function f is a quadratic function. The graph y equals f of x in the xy plane has a vertex of -5, -8, contains the point -6, -10, and has a y-intercept of at 0a. The graph of y is equal to 6 times f of x, has a y-intercept, so this is graph amplification happening. And I'm asked what is the positive difference between a and b. Okay, so again, here I'm given the vertex, so I'm inclined to want to use y equals a, x minus h squared plus k. Okay. When I'm given the vertex and also 2 coordinates, so this is my hk, and this could be my xy. In doing so, that will help me define what the a value is. Okay, so I can use this knowledge to find a. So I would just plug this in. Okay, I'm gonna plug it in directly. Okay, I'm gonna put my xy coordinates in, so -10 is equal to a, my x is -6. My h value here, if it's negative here, it will be positive inside, and then -8 here. Okay, so this would simplify to -10 equals a, this is -1 squared minus 8. Move the 8 to the other side, this becomes +1, so I get that the a value, it's -2. Okay, so then I can write the total complete version of vertex form, which would be -2 x plus 5 squared minus 8. Okay, and then I'm asked for what the y-intercept would be. So the y-intercept is, as you see here, when x is equal to 0. So all I need to do is then plug in the 0 value for x, just put it here in a different color, and then I can solve and get, what the y-intercept is here. So this would be y equals -2, this becomes 5 squared, 25 minus 8. So this is positive 25 times 2, it'll be -58. Okay, so that means that the y-intercept it occurs at 0, -58, and this correlates to my A value. Okay, and here's where knowledge of graph amplification can come in handy. Then it asks me for this, the graph of y equals 6 times our original function. So this one has a y-intercept at 0b. What is the positive difference between a and b? So for this one, there is a shortcut, but remember that in graph amplification, x-intercepts stay the same and everything else changes. So like I can go back 6 times f of x just to show my original equation we have was -2 x plus 5. I'm amplifying this one, right? So what actually gets multiplied would be like this coordinate here by 6 and also this coordinate here. So 6 times f of x would be equal to -12. The x coordinate stays the same. And then it'd be -48. Then I can plug in 0. I'm going to show all the steps and then I'll show you the shortcut. So now I'll just plug in 0. So it'd be -12, 0 plus 5 squared minus 48. This is going to be -12 times 25 minus 48. And then in doing this, this is -300 minus 48. So that tells me that's -348. Okay, so that is the y-intercept of the graph amplified 6 times, and that's 0b. Okay, so I have my b value, my a value, and then I can find the positive difference between the two. Okay, but also just to show the shortcut of that one, I could have simply just multiplied a -58 times 6, because -58 times 6 is -348. Okay, because like I know everything will just be amplified by or multiplied by 6. Okay, but anyways, to find the positive difference, so remember it says positive difference, so I'm going to be using absolute value here. I would just take between a and b, so it would be -348 minus -58. And remember here, careful, distribute the positive, so it becomes -348 plus 58. And that becomes -290 as for the positive difference, so it'll be 290 as the answer. Isn't that amazing? But I would just be really comfortable with these functions, whether it's exponential, vertex form, factored form, and knowing the rules of transformations and graph amplification. I think that'll be really important for the exam. Whether you're taking the May exam, it's 2 days from now, or any exam for the SAT, it's really great to know these concepts. Okay, so those are really the really important things or concepts that I believe will be on the digital SAT. I do have just a little bonus here for concepts that are on almost every single SAT exam that you should already be familiar with, but I definitely think you'll see a discriminant question. They show up on almost every SAT exam. So I just want to show a couple difficult ones, or seemingly difficult ones. But just remember the discriminant, it's always the part of the quadratic formula underneath the square root. So it's the b squared minus 4ac. And basically the discriminant tells me if there's 2 solutions, 1 solution or no solutions of the parabola. So if there's 2 real solutions, you need to know this, that it be greater than 0, 2 real solutions. If there's 1 real solution, it's equal to 0. And if it's no real solutions, we set the discriminant less than 0. Okay, so basic question, and I always know it's a discriminant because in addition to x, there's an additional variable. And then it says in the problem, in this case, like in the given equation, b is a constant. For which of the following values of b will the equation have more than 1 real solution? Okay, so this is saying that my discriminant, b squared minus 4ac, should be greater than 0 because it's more than one, two real solutions. And then I just have to go here, plug in my value, so b squared, just to show like a is equal to 64, b is equal to b, and c is equal to 25. And so I would plug in 64 for a and 25 for c. So quite large. But so 4 times 64 times 25, that is b squared minus 6400. Move the 6400 to the other side. And then super important with this concept, which makes it one of the more difficult ones, is that I need to, whenever you have inequality with a square, you need to consider the absolute value of the square. So when I take it, there's two situations. In this case, since it's greater than, like I'll take the square root. There's one case where b is greater than 80. That's possible. And taking the absolute value would also be b, I flip the sign and I negate it, is less than negative 80. Why? Because negative 80 squared will also produce a positive result. So I need to consider the two scenarios where it's greater than or negative. Okay, so b is greater than 80. Well, none of these are greater than 80, so I know I'm dealing with this one here. It's less than negative 80, so this is definitely a trap. The only one that's less than negative 80 is our amazing answer choice, negative 91. Okay, so be familiar really with that concept. If you take the square root with an inequality, you need to consider its two values, its positive and negative value, and you need to do what I did here. You flip the sign, you would negate it. Amazing. And continue our journey. So this one, very common to appear as well. In the given system of equations, c is a constant. The system of equation has two distinct solutions. So again, I know that the discriminant should be b squared minus 4ac is greater than 0, which is all could be the value c. Okay, if you see this, you want to immediately substitute this in here. So let's do that. It'd be x minus c is equal to negative 2, x minus 12 squared. Move everything over and set it equal to 0. So that would be negative 2, x minus 12 squared. And then we would have minus x and plus c is equal to 0. Okay, so in this case, I'll need to expand the brackets. So it'd be x minus 12, then minus x plus c equals 0. So then it becomes x squared. This would be minus 24x plus 144 inside here, minus x plus c. Sorry. Oh my goodness. Sorry. We should have this, well, all greater than 0. Greater than 0, greater than 0, and greater than 0. Okay, now I can distribute the 2 to everything. So that would just be negative 2x squared plus 48x, and then minus 144 times. So minus 288. And then minus x plus c greater than 0. And then just to simplify that, that's negative 2x squared plus 47x minus 288 plus c greater than 0, right? Okay, so, okay, sorry guys. This is all equal to 0, but now I have my equation. And then I can go here and be like, okay, so b squared minus 4ac, that's greater than 0. My b value, it's 47 squared minus 4, 2, and my c value is actually negative 288 plus c. And then greater than 0. And then let's just solve that out. And here you just need to be super careful with the negatives. So this is 2209. This is -4. -4 times -2, so it becomes +8. And then, so imagine like I have this +8 being distributed to this negative number. So it'd be 288 times 8, which is minus 2304. And then here it's +8 plus +c, so plus 8c greater than 0. Oh my, I'm running out of space. Okay, so then we have 2209 minus 2304. So that is -95. I'm going to move the 8c over, -8c. Divide each side by the negative. So since I'm dividing by -8c, remember whenever you divide by a negative number, I'm going to flip the inequality. So that will give me 95/8 is less than c. Okay, so here, or like c is greater than 95/8. Okay, so this is definitely a trap answer because remember it has to be greater than. 95 divided by 8, it's like 11. 95/8 is 11.875. So I know then the only one that's greater than 11.875 is 17. Okay. Wasn't that amazing? So just be familiar with all these concepts, review geometry, review the functions, the rules of amplification, transformations for sure. Be super comfortable with all types of the quadratic equations, such as vertex form, standard form, and factored form, just the root form. And also know your discriminant, because I feel like that will definitely appear. So, I mean, there's a wide array of constants you know. I just feel like these are the ones that you definitely 100% should have down. I think they'll appear on your exam. And if you, well, and that's really what I have to say. Just if you're taking the exam this Saturday, good luck. Let me know if you have any questions or you want me to cover some other concept in the video. I hope this is helpful. I hope it helps you on the exam. And then check out my other videos for other resolutions of problems, as well as the English SAT predictions. Okay, so good luck, and I hope this was helpful.